This is a catch-up video for anyone that's been struggling with getting work done. We've spent the last couple weeks studying this new type of function called a quadratic function. We've explored it. There's a lot of real-world examples that you might have missed. Roller coasters. What else? Oh, diving. Into or jumping, throwing a ball up in the air. All of those things can be represented using a quadratic function of one type or another. So that's our new type. Say it. Quadratic. Say it again. Quadratic function. Okay? There are two types of quadratic. There's one type of this quadratic functions. But quadratic functions, there's some unique things about a quadratic function. Okay, and these are the 5 main things that we need to find and know about a quadratic function. Okay, some vocabulary along with what you need to be able to find them. Okay, one big thing is that the shape that you see here, this up and down, is called a parabola, and every quadratic function has a parabola. Just like linear was a straight line, right? Quadratics have something called a parabola. That's the name it was given. So there's some cool things about it you would have explored. Okay, parabolas are symmetrical. That means they have a line of symmetry in it. We call it the axis of symmetry, which splits it in half. You can see it right there. And if you folded it on the axis of symmetry, if you remember from maybe when you were younger, both sides, this side will match up with this side. So it's very much symmetrical, which is one of the cool features of it. So we call that line the axis of symmetry. It cuts it in half. Okay, Kev? Or whoever. The axis of symmetry, there's an equation for it. Vertical lines always come in the equations of x equals whatever x value it goes through, the axis of symmetry. Now you can see it's 1, 2, 3, 4. So axis of symmetries have equations. X equals 4, right? They'll all come in the form x equals 4. That's all vertical lines. The vertex is what we call the high point or the low point. In this case, this parabola has a high point. Okay? So, and the axis of symmetry goes through the vertex. It kind of has to, because the vertex is the one high point or one low point, so it has to go through it. 1, 2, 3, 4, 5, 6, 7. And, which we'll talk about more, but it's kind of like a cool feature. That the axis of symmetry goes through the vertex, and you can see that the axis of symmetry equation for that line, see the 4? It's the same as the vertex 4. It has to be because the axis of symmetry goes through the vertex. Okay, so as I go in the next part of the lesson, you can actually find the axis of symmetry pretty easily for any quadratic, and then you can use that to find the vertex, which is kind of useful. Okay. Quadratics have Y-intercepts, where the line crosses the y-axis, and not always, but they do have X-intercepts, and they're the hardest to find sometimes. In this case, it's not too hard to find on a graph. Boom. It has 2 X-intercepts. It doesn't always have 2. It might have 1, right? Or it might have none, actually. Okay. So those are the key features of a parabola. That you've been trying to explore and find. Okay. A couple key things is we can find out all these features without having to graph. So if you haven't graphed, all right, you missed that piece, but that's okay. We can still find all the key features of a parabola. In this case, it can model like throwing a ball up in the air. Can you see it? You throw a ball up in the air. You kick a ball up in the air. You shoot a basketball. You shoot a rocket in the air, right? Okay. But parabolas come like this, but they also come like this, like going down a roller coaster and back up. Okay. So this one, vertex, has a maximum, and this one has a minimum. Like so. So there's 2 types of parabolas, this and this. Okay. And you can know just looking at a quadratic function. Oh, I forgot to include it. So a quadratic function is any function that can be written in the form ax squared plus bx plus c, okay, where a, b, and c can be any number, except a can't be 0. But it's okay for b and c to be 0. So we're going to see quadratic functions that have a, b, and c filled out, like 2x squared plus 3x plus 5. They have a, b, c. We might see a quadratic function that the b term is 0, but we do have a c term. But what's the point of writing 0x, right? So we can just get rid of that, and you'll see it as 2x plus 5. We're going to see quadratics where the c value is 0, right? 2x squared plus 3x plus 0. But again, mathematicians don't write the 0, right? So we'd see it like that. And we might just see it where both b and c are 0. And we don't write it, so we'll just see it like that. Okay. The only thing, we have to have an a value. Doesn't matter what it is. It can be any number except it can't be 0. Okay? Because if it's 0, you have no x squared, and you're turned into a linear equation, which we don't want. We want a quadratic. All right. Cool. So you could explore if you wanted to go back. It's fine. At this point, we're trying to catch everyone up. So these are the notes that I gave to students to write down in the notebooks. And we can find 4 of the key features without having to graph. Okay. First, which is the easiest, is the Y-intercept. The Y-intercept for a parabola or quadratic, when it's written in this form, is the c value. It's the y value of the Y-intercept. Boom. You might say, oh, that's kind of like y equals mx plus b, right? Where the b is the Y-intercept, right? And actually, which we don't do because we didn't want to confuse you, you could almost think of it as y equals bx plus c. You know, because m and b are in the, this is just arbitrary, but think about this, bx plus c, that's a linear. You add the ax squared, now you got a quadratic. So the c in both cases is your Y-intercept. Okay. Your axis of symmetry, which you would have explored and would have showed you, is just a simple formula to find. You take the b value of a quadratic, if it's in this form, you divide it by -2 times whatever the a value is, and that will give you the equation for the axis of symmetry to any quadratic. Okay. We didn't explore it because it's very long and it's not worth our time. It's a very simple thing. You use it a lot. This will find us the axis of symmetry. Okay. Who cares about the axis of symmetry? Well, the axis of symmetry is really important because it can help us find the vertex, right? Because it goes through the vertex. So in real world examples, you throw a ball up in the air and you have an equation for it. You want to know, does it reach 100 feet, say, or you're shooting a rocket in the air and you have the equation that someone calculated. You could find the axis of symmetry and use it to find the vertex, the highest point, or the lowest point. We did this with a dive into the water. We found if it was safe for someone to dive, right? So was it safe for this person to go down here, right? If you're going on a dive, we could find the vertex. If the vertex is below the level of the pool, bottom of the pool, and you're going to crush your head, so it wouldn't be worth diving. Okay? All right. I just gave you notes on it. No, I didn't. Okay. So you can tell whether the vertex is going to be a minimum or maximum. We explored it, but you're missing that part. You just have to remember, if the a value is greater than 0, so it's a positive number, it's going to be a minimum. If a is a negative number, right? Positive a minimum, negative a maximum. It's kind of like the reverse. Okay. So this is the equation for the vertex, or the point for the vertex. And it looks funky, but it's really not. The vertex is the point b over -2a. So take the b divided by -2a for whatever quadratic. That will be your x value for your vertex. And then because we have a function that calculates f of x or calculates y, we can take our x value, plug it in, and get the y value. Okay. The one we're going to leave for now and spend a lot of time on is finding the x-intercepts for a quadratic and what that means. Okay. So this is an example of one that I wanted students to do. I'll just show it to you if you want to pause it or not look at it and just write down the equation, say, and try it. So I want you to find the key features of the parabola that you can find right now. So we have y equals x squared plus 6x plus 5. Right? There's a handout I'll post if you want to have it as well. But here is the graph of it. Can you find the key features? Right? This is the graph. You could use the graph, or you could use the rules that we did up there. So I'm going to show that over here. So the y-intercept, if you look at our notes, is the c value. So boom, it's 5. The axis of symmetry is x equals -3. You do that by taking the b, which is 6. -2 times whatever the a is. The a in this case is 1, right? Because if there's no number there's in front of a variable, it's 1. So if you do the math, you get the axis of symmetry at -3. The vertex, since a is greater than 1, greater than 0, since its a is greater than 0 and hence 1, we're going to have a minimum. Since a is +1, we're going to have a minimum. Okay, and you can see the graph has a minimum. Right. The axis of symmetries, the x minus 3, the -3, excuse me, is the same as the x coordinate of the vertex. So you can just plug it in right here. To find the y value of the vertex, you have to plug it in over here to our function because it shoots out y, or f of x. I did the math here, and I got that it happens at -4. So I found the vertex to be -4. Alright, and then what I did over here was just to come and take a look to make sure I agree that it all worked. So we said the y-intercept was 5, was it? Yes. We found the axis of symmetry to be -3. Yes, there it was there. It is a minimum based on the a value. The vertex happens at -3, -4, which is what we calculated. So for anyone that's out, that's catching you up. You need to be able to find all the key features of a quadratic using these notes up here and practicing. So I'll include this one along with one other worksheet. And again, it's just for people that need to catch up. Do this and the other worksheet, and you'll be caught up. Okay? Send me questions on it and stuff like that. But again, these are the main ideas we covered over the last 3 weeks, slowly covering the key features of a quadratic. So again, it's a quick way to get caught up. I'm going to send it out to the people who need it, and you send me back your work on Google Classroom. Okay? All right, bye.